Okay, guys. So on the second meeting of our probability topic, we're gonna discuss about even chances and uneven chances. I think I don't have to give you the description because it's very hard to describe which is even and which is not even chance. So for example, I have two circles with, let's say, the same amount of color that is drawn in each of the sector. I draw for the first this, and wait a moment. So this is the first spinner, and this will be the second spinner. Consists of four colors, but I put it in the different arrangement. Okay, so we have this pointer, and you spin the wheels about the rotational axis here, and we have same colors. For example, we have yellow, and then blue, red, green. My question is, which will give you the even chances for all the colors, left or right? Even is equally likely, equal probability, even with equal. Left side, right? Why? Because the probability of getting blue is 90° out of the total, right? So the expected over the total, which means 1/4 or 25%. The same way on yellow, red, and green. So P blue equals to P yellow equals P green equals P red, 1/4. This is called an even chances. Or we can say equal chance. That's better way. Equal chances. Equal probability. But on the right side, we see that the shape or the sector of each color are different. The same way, the same sector is only blue and green, right? For example, this is 45°, this is 45° also. So to calculate the probability of blue, we cannot do 1/4. Of course not. One color out of four colors. No, that's not how it works. You need to understand about the angle, right? About the angle here, 45°. So 45 out of total 360. Does it make sense for you? Or you can simplify 1 out of 8. How about P yellow? Georgia, what is P yellow? What is the probability of getting yellow? Easy. The answer is 180° over 360°. Why? Because the angle on yellow color is 180° straight line. The total circle is 360°. So you can just write 1/2. I think you don't have to think of the degree. You only focus on this yellow. And the other is not yellow. According to your primary lesson, if you attend primary, and I assume you attend primary, how many circle of this? 1/2. That's it. No need to think of the angle. Angle is the hard way to understand. This is also the green color. You don't have to memorize the angle. You just look. If you separate this into equal parts, all the shapes should be the same, right? So the green color is only 1 out of 8 equal parts, right? That's it. 1 out of 8. You don't have to put 45 over 360. It's a waste of time. Red, without using angle, how many parts of the probability? 1 out of 4. So actually, this probability topic requires your primary fraction logic. If you don't memorize, if you don't understand fraction, dream on to do this probability way. Probability of red circle split into 4 equal parts. See, 1 out of 4, total 4. Again, the basic concept is about shading. Okay, guys, my question is, what is this shaded part fraction? Fraction. 1 out of 8. Make it more. 1 over 16, yeah. But better use circle than square. And the total probability, if you add all the total probability, it also go to 1, right? So the total, as always, 1. Total probability 1. Okay? If you add 1 over 4 plus 1 over 4 plus 1 over 4 plus another 1 over 4 is 1. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 8 is also 1. One whole circle. But what is the difference between left and right? Left is equal chance, but in this case, it is uneven chance or unequal chance. Unequal chance. Okay. Okay, I think it's quite simple to be understood. Equal chance and unequal chance. Just change the title. Equal chances and unequal chances. Understand so far? Okay, do you understand now? Okay, nice. Let's do the work example. The practice now, I mean. So let's practice some questions on this part. There you go. Here. See? How do you solve this? Practice now 6 you find in your book. You have your book with you right now. A circle is divided into sectors of the different color. So we are focusing on the angle right now. What is the angle of the unknowns? That's first. Don't focus on the question. Focus on completing the angle. How many color we have? How many colors? 5. How many degree in total? 360. What is the angle of green? Why? We have the sign. What is pink then? Oh, so fast. Pink, pink. 60, how come? Yeah, or 360 minus all of this, right? So, or this is a straight line, it's given. We assume that this is a straight line. Or this is 90 degree also. 90 minus 30, 60 degree, right? So you can do so many ways on finding the pink area, pink angle. Okay, find the probability of the red sector, guys. P red 135 over 360. Okay, Keiko, pink sector to ensure your understanding. What is pink sector probability? $60 over 360, that's right. So just confident with your answer. Yellow sector, Georgia. Sorry, where is yellow? Huh? No, no yellow. So what is the probability of nothing? 0, that's right. Right? Blue or orange. Ah, there you go. Blue or orange. So it can be either land on blue or land on orange. Just add the number. 30 plus 45 over 360. Easy, yeah? You can simplify without any further degree. Don't use the degree because probability has no unit. Okay, you do it fast. 135 divided by 360. 3 over 8. 1 out of 6. 0. 75 over 360. Okay. You may use your calculator or you can do it manually by simplifying the fraction 5 over 24. Wait. Yeah. Look, that's the way you do. Easy, right? All good? So what is the formula of probability? As always, the formula of probability of E equals the outcomes of E, expected value or expected outcomes over the total possible outcomes. Expected outcomes over the total possible outcomes. Like we did previously on our first meeting. You can watch the video on our first meeting. Just find it probability 1. Next, we go to next question. Last question, actually. Last 2 questions. Practice now 7. Okay, I will give you some time to think, not lazy. Focus on the question. We are dealing or we are trying to integrate between probability and what is it? Probability and wait, what did I do just now? Probability and algebra, that's right. Okay, you can pause the video. You try to do it right now. Okay, we continue for practice now 7. There are 2 questions, but I just show you one. Look at the question. There are 12 green balls and x plus 2 yellow balls in a box. Do we have the value of x? No. So for number 1, part 1, find an expression, the total number of the balls in the box. So the total number of balls is green plus yellow. What is green balls? 12. What is yellow? That's it. So what's the simplest version? Yeah. 14 plus x or x plus 14 balls. That's it. Okay. Question 2. A ball is drawn at a random from the box. Write down an expression in terms of x that the probability of the ball is yellow. So what is the probability of taking yellow balls?
12 plus x plus 2.
X plus 2 over this. Or you can simplify x plus 14. Okay. Why? Because yellow, you have to simplify. Over total. Total has to be simplest version. That's it. Part 3. Given that the probability in part 2 is 2 over 5. Oh, simple, guys. Find the value of x. So the probability in part 2 is 2 over 5.
X plus 2 over.
Yeah, x 2 over 5 equals x plus 2 over x plus 14. Or x plus 2 over x plus 14 is 2 over 5. You can do either way. What next? How do you find x? Cross multiply, that's it. That's the smart way. 2 bracket x plus 14. 5 bracket x plus 2. 2x plus 28, right? Do the, what do you call, rainbow rule or distributive flow, same way. 2 times 14, 28, 5x plus 10. Then you can find the value of x. Okay, not enough space. I rewrite one more time. So you put x to the left, or right, up to you, but I put it up to the left. 10 minus 28, right? Get it? Do you understand so far, guys? Okay. 2x minus 5x, negative 3. 10 minus 28, 18. 6. That's it. So what is x actually?
6.
Oh, I mean, what is x on the question?
X plus 2.
Yeah, the yellow 8. Yep. Yeah, here. Yeah, the value of x is finished, but I want to go further. What is X actually? X is a part of yellow balls, right? Okay, number 2. Last number. Yeah, not easy for number 2. There are 28 boys and 25 girls in a school hall. After Y girls leaves the hall, the probability of selecting a girl at random becomes 3 by 7. Okay, guys. So what is the probability? Is the probability represent the total number of students? No. The probability is to show the simple fraction of a certain value, right? But the real value is 28 boys and 25 girls. So we have 28 boys. Wait. Boys, 28. And then girls, 25. After Y girls leaves the hall, so this is before. So we have to understand there is a time where it is full of attendance, and there is another time where the girls leaves the place. After is the boys change? No, still 28 is the girls change?
Yes.
Yes, how much?
25 minus
There you go. 25 minus Y. After the Y girls leave the hall, which means you subtract, the probability of selecting a girl at random, probability of girl after here is 3 by 7. What is the probability of girl then? 25 minus Y over?
Over 28 plus 25 minus Y.
Mantap. The total is added up. Okay, 25 plus 20, 28 plus 25, 53 minus Y. Minus 53 minus Y. Make sense for you? Just think mathematically. Think logically as well. So this is a pure logic after, not before. Before is only for the clue on the right side, on the after part. Let's focus on solving the Y. Algebra again, right? What to do?
Cross multiplication.
Yes, you do the cross multiplication again. 7, 25 subtract Y. 3, 53 subtract Y. Okay, Cisco. Distribute. No calculator. Oh, mantap. 175. Okay. Do you took any coupon? Huh? You do it by yourself? Okay, that's a way of thinking. Try to learn to count mentally. Yeah. Okay, nice. So keep the negative 7Y to the left and plus 3Y. Next. 159 stays. Okay, Cisco, you do the rest. Four. Yeah. Yeah, it's not easy. Yeah, there you go. Negative 16. Right? So Y is 4. The question is find Y, right? Okay, what is Y represent?
One of those.
Yeah, the number of girls who leave the party. A whole, yeah, whole. Okay, whole. Okay, that's all for today. So now let's do the exercise, guys. I already put the exercise here. Secondary 2. Wait. Semester 2. Oh, guys, we finish all, but one more I forget one more, experimental probability. So experimental probability is actually same with theoretical probability. Why? Because if you do the experiment, it always tend to get near to the real probability, to the calculation probability. Let's see, guys. For example, I have a coin. Uh, do does anyone have a coin, guys? I don't have a coin actually. Please borrow coin. I will show in the video right now. Yes. I am opening my camera. I stop the share screen. Denzel. Oh, thank you. So, for example, we have a coin here, 100. This is called head, and this part is tails, the picture part. So, if I flip the coin, for example, what is the probability of getting head? 1 out of 2, right? How about, let's check. I will share the video, share the screen. Why 1 out of 3? No. Yes, I'm still recording the meeting. Am I? Oh yeah. Oh yeah, that's right. So I have a coin. It's either head or on one side and tails on the other side. Okay. Now, the probability of getting head is 1/2. The probability of getting tails is 1/2. So if I toss the coin, this one coin, 1,000 times, what is the expected value of having a coin, a head?
500 and 500.
500 and
500.
500. This is called theoretical probability. But in real life, can we have 500 sharp? If you toss the coin 1,000 times? No, it can be
One.
more or less,
Yeah.
right? Depend. But is the number will be getting nearer here? Of course, it cannot be 1 and 999 unless unless the coin is not even, is weighted on one side. Yeah. So if it is even chance, we can conclude that the theoretical, so this is actually a theoretical answer, theoretical expected value. And somewhat we need to understand there will be some bias. What is bias? A slight different value that we get. It's either it can be 499 and 501. What else? It can be 503 and 497. Yeah, 497 and so on. The total has to be always 1,000. So this is called, the first is theoretical. The second here with the random number but near to theoretical value called an experimental value. But the more you do, I want to increase the total tossing times by 10,000. The probability will getting nearer to 0.5. Make sense? Nearer to 0.5. That's only for a coin. How about the dice?
6 sides.
6. So it is 1/6. So the more the toss, or the more the, what you call, the trials, the nearer to the theoretical value. Okay. Now, I stop the sharing. You can see my face again here and the coin. Please someone do me a favor, guys. Toss this coin 2,000 times. Do you want to do that?
Yeah.
2,000? 2,000 times tossing a coin? One coin. One coin. Why one coin? Because we are talking about the probability of single event, not double events. More than one, yes, it can be 2 coins. If 2 coins, the probability will getting like this, guys. Okay, since you asked, coin 1 and coin 2. If you toss 2 coins, it can be either head head, head tails, tails head, tails tails. How many total outcomes we have? 4. 1, 2, 3, 4. So each of the arrangement will be evenly 1/4, 1/4, 1/4. You combine this because this is two different value, 1/2. And sorry. If you total all the numbers, you will get 1 also. How about 3 coins, guys? 2 coins easy. Head, tails, head, tails. Okay, 3 coins. How to arrange it, Jason? Triple H.
HTT,
Okay,
HHT,
okay.
and then PHH,
Nice.
PTH.
Different, yeah, different. HHT and PHH is different. Sorry? We have 5. Are there 6? Are you sure? Did we miss some arrangement? HTH?
Oh,
THT? Oh, okay, so much. One more. Oh, okay, finish. So this is in a random order, guys. So make it more rearrange. So mathematics is about rearranging and finding the logical way to solve or to list down all the value. Use the tree diagram. So the first possibility is head. The second will be head or tails, right? You are determining in the very, very detailed way, right? Are we finished?
oh,
No. Second, do the same thing over. You won't miss any possible outcomes. So how many possible outcomes? 8. Triple H, HHT, HTH, hati-hati, tahi-tahi, salah. THH, THT, telinga, hidung, tenggorokan. TTH, TTT. Oke, oke, gampang ya. Hit, right? So my question is, find the probability of getting all phase are the same. What is the probability of all phase are the same? Cuman 2 kan, only 2, right? So 2 out of 8. Probability of all tails. 1. Only this, right? 1 out of 8 of the total. Probability of at least, oh my goodness, 1 tail. At least 1 tail.
4.
How come? At least 1 tail. 7.
Oh, wow.
Yeah, at least 1 tail. It can be 1 tail, 2 tails, or 3 tails, right? Not this. Make sense? 7 out of 8. At most 2 heads. Okay, at most 2 heads. Sama, 7 over 8. At most 2 head. No head, not this also. Make sense? At most 2 heads. 3 heads, 1. At most 2 head maximum. No head. Yeah. 1, 2, 3, 4, 5, 6, 7. Read or comprehend the probability understanding. At most 2 head. At most means the maximum amount of head is 2. 0 head, take 1. 1 head, yes. 2 heads, yes. Take 3 heads, no. So everything except this. Yeah, at most, at least, at most, and so on. They are quite tricky, especially for those who use English as the second language. So you try to understand the English and comprehend the sentence. Okay, I think this is too far, but that's how you do. How about dice? How about dice, guys? I have how many faces we have? Okay, 6. How about 2 dice? 2 die. 2 dices are 2 die. dice number 1, dice number 2. 1, 2, 3, 4, 5, 6.
Oh,
Okay, please wake up. No one is sleeping. Okay, 1, 2, 3, 4, 5, 6. How many possible outcomes if 2 dice are tossed? How many lot if it's 36? It can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Sit properly, guys. Don't lie on your table. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, and so on. So we have 36 possible outcomes. My question is the probability of the uh total number of dice. Total number means the top side facing is 3. What is the total number that added up by 3? How many possible? 2, 1, 2 plus 1, 3, right? 1 plus 2 is 3. Are there any other else? No. So 2 over 36. What is the probability of total 10? Yeah. If you add 2 faces, you get 10. Where is 10? 5, 5. Yeah, that's it. 1, 2, 3. Right? Look at the pattern. Are there any other else? Any other else? No. You add the number 4 and 6 becomes 10. So 3 out of 36. What is the probability of same numbers, same faces? 1, 2, 3, 3, 4, 4, 5, 5, 6, 6. 6, right? Yes, that's it. So we go to advanced right now, but you understand, right? Okay, Adeline, the probability of total 5. Total 5. Where? Is this 1 plus 4, 5? Yeah, okay. What else? So we have the diagonal arrangement, and we don't have any other else. 4 over 36. Easy, right? You know how to do, right? And we have so many possible questions. For example, facing even, both are even numbers, right? Both even, 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, and so on. Later. Okay, I don't want to continue this too much, too far, but that's about the probability. And the probability is actually very, very useful in your daily life and to predict the outcomes or to predict the stocks. If you want to go further about the economic, what do you call, economic condition in a certain stocks, in a certain offices, and so on. Okay, I think that's all for our meeting. I'll see you later. Bye.